right, so today we're going to be talking about simple collision detection in Java. We're just going to use two rectangular things, an object and a player. We can apply this same thing to then animated objects using the location. So let's start out. So we've got a little Batman here and this beautiful rectangle painting of the sun. So each of these has two main attributes we're going to care about. It has a location and it has its dimensions. So this Batman has a position, okay? Let's call it the player X and player Y, okay? So that's the Batman's location, because every rectangle we draw in Java, it starts at the top left and fills down into the right. And then it also has dimensions. So it has some player width. I'll just call it player W. And then it also has a player height, which I'll just call player H. Okay, and then down over here on the other one, let's use black. This one also has a location, so let's call this our object X, comma, our object Y, right? So that's the location of the object, top left corner, and then the rectangle is drawn down and to the right. And now also this has an object width. Okay, let's call that object W. And then it also has a height, okay? So the question is, when will these two overlap? Okay, so here's object height. Okay, now when will this overlap? Well, if I drag my Batman, it's only going to overlap when, boom, and there's two cases here. Either I drag it so much so the player location is actually on top of the sun, right? So if at all that top corner of my Batman is inside the sun's rectangle, well then of course they'll overlap, right? Let me just make this bigger, right? Of course they'll overlap. However, it can even overlap if I go out to the left side of the screen and yet the player's width, notice the player's width down here, is still going over onto the sun. So even though my position of my player is not inside the object, it is within the player's width, right? Here's the player's width carrying it over into it, okay? So again, even though the player's position is outside of the object, they can overlap because it's within the player's width of the left side, right? Here's the left side of the object. Here's the left side of the player. And so since their positions are less than the player's width, they're still going to overlap a little, okay? Well, I could also do the same thing by moving up. I could see, wow, as we go above, again, even though my player position here is outside of the box, because the player has some height to show up on the screen, and its height still overlaps it onto the object, well then, we still have an overlap. Right? And we could even have the case where both of these come into play. So we could have the player's position be up and to the left, where as long as it's still within the player's width on the left, as long as it's still within the player's height up above, then they're still overlapping. As soon as I go wider than the player's width to the left, they're no longer overlapping, because the difference between the player's position, which is the left side, right? That's where the point is, the top left. And the object's position is more than the width of the player. So since they're further than that width away, they do not overlap. Same thing on top. If I start inside, they're still overlapping because that player's height. But if I go further than the player's height above, they're not going to overlap anymore. So what we get is we get a rectangle where if the player's position is inside the object, or a little to the left, or a little above, then they overlap. So to simplify that, going down, we have our player overlaps if, and again, I'll bring my Batman down here. Okay, this is going to be helpful for us. My Batman overlaps, okay, if it's within the player's height above, if it's within the player's width over here, or both, if it's up into the top left, but still it's within its width. It hasn't left the player's width. It hasn't left the player's height. So as long as the player's position is somewhere in this box, it will be overlapping with the sun that's down here. Okay, so let's just get rid of this. All right, so, or actually, let's not get rid of that. Let's drag that back up here for you guys to play with if you want to grab this. Whoops. Okay, so here's what we've got. This is the region that if we have our player's location in this box, okay, notice that if it's inside the object, of course they're overlapping because the player is inside the object, but also within that player's width to the left here, and within that player's height up above. So if it's within those dimensions of this center object's location, we have them overlapping. Okay, so I won't go over that and repeat myself too much there. If you have trouble, again, I'd restart the video and kind of walk through that logic. Okay, so really what we're trying to code here then is our object in this, right? Is our object's position, our player's position, so our player's X and Y. So again, we called that our player X, comma, player Y, right? So our question then is this position, is this point somewhere inside this box? If it is, they're overlapping. If it leaves this, they're not overlapping anymore. So our player will hit our object if the point is in this region. And how do we test if it's in this region? Well, we do it in two separate ways. We say, is the X position of the player in between these lines? So is the X position of the player in between these lines? That's right here. So is the player's X position less than the right side and more than the left side? Okay, well, let's look at the left side first. So is this player, whoa, we don't want to get too crazy there. Is the player's X position, I'm just having fun, sorry. So is the player's X position greater than the right side? So in other words, if we start at the object's location and subtract the player's width, because again, we start with a 0, 0 up here in the corner, and this is positive X in this direction. So if we take the object's location and subtract the player's width, then what we've got is the X dimension here, or the X location here, right? If we start at the object's location and add the object's width, we now have the X position of the right side of this box. So what we're saying is the player's X somewhere greater than that left barrier and somewhere less than that right barrier? So in other words, the first line says, is the player's X between these walls? Okay. Then we also need to say, and the Y has to be between the top of the box and the bottom of the box, right? So is it, and again, because we're starting up here in the right with 0, 0, and going down with positive Y, which I know from your experience with math is upside down as you would consider it. But our question then is it the Y greater than this top barrier? Because this is up near 0, right? 0 is at the top. So is it greater than that Y value, but less than this Y value on the bottom? Is it between those two Y values? And so the way we do that is we say, well, if we start at the object's location, we would subtract the player's height, and we would add the object's height. So the question is the player's Y less than the object's Y plus the object's height? So that's the bottom barrier. Is it less than that bottom barrier? And is it greater than that top barrier, right? The object's Y minus the player's height. So the question is the Y between the top and bottom? And separately is the X between the left and the right? Okay, so that's it. That's what we're coding here. If the player's X and Y is in that region, they collide, then you want to say, okay, lives -1, reset the player. If the lives is less than 0, game over, whatever conditions you want to have happen. But this is the conditional you would write. Now, looking at this, though, we have one problem, okay? Now, remember that in Java, the less than and the greater than are binary operators. That means they can only handle two things. We can't have is A less than B less than C less than D. It doesn't know how to handle that because the first thing, right, it would be like, okay, is this true? Yes. True. Is true less than what? How is true less than a number? So it gets confused on where the priority, where the order of operation. So it's a binary operator. It only compares two things. So we can't compare three separate things as a true or false. So what we're going to do is we're going to split this up. We're going to say, okay, this isn't actually one big conditional. It's two separate ones. We would take that original and say, well, we want this to be true, and separately we want this to be true. So we split it up and say, okay, is the x greater than this? And separately, is the x less than this? And then we just say both must be true. So it's one conditional as the x between the left and the right that we split up and say that's really, is it more than the left and is it less than the right? So that means, is it between the left and the right of that box? So in summary then, what we've got is our player and our object are going to collide if the player's x and y is somewhere in this box, okay? If the player's position, we've got this, player over here, if it starts moving into our region and its position ends up being, its location, that top left point, if it ends up being somewhere in this box, then they collide. So we write that as, is the x between the left and the right, and is the y between the top and the bottom. And then we have to split that up, okay? And the way we split that up is we say, okay, so dealing with first the left side, then the right side, then the greater than, so that's the top, and then less than, so that's the bottom. So we've got 4 different barriers to check. And if it is greater than, less than, greater than, less than, it is in between those 4 walls, then your object is going to collide with your player, and we will have some conditions. So I'm going to pause the video now and switch over to my computer and show you what this looks like on Notepad++. Okay, so what I've done is I've taken the example that we previously have for our class and I've added to it. The main thing I wanted to do is I wanted to show you both a static object and a moving object and how they collide. So let's just open this in command prompt really quick, and let's just, I've already compiled it, so let's just look at the runner. So what this does here is with the arrow keys using key listener, I'm able to move my object, or move my player. And then if my player ever comes in contact using the code we just talked about with my static object, it will reset. Or if it ever comes in contact with the moving object, it resets. That happens no matter where the player hits it. I could hit it, down at the bottom. I'll just wait for it really quick. And as long as they're overlapping using the code we talked about, that's going to detect the collision, okay? So let's look at the code really quickly. So what I've done is, rather than using actual numbers, I've gone ahead and created an x and a y and a width and a height variable for each obstacle. Now, notice that the first obstacle is not changing width or height. It is not changing its x or y. So you could have just used numbers in those positions down below in the conditionals where I write the if and else. You could have just put in the 100, the 50, the 200, if you know its position. The only time you have to use a variable is when your object is moving or your player is moving. Then you need a variable because it'll be different each time the loop runs. So up here, I went ahead and created a variable for each just for clarity. And then what I do, also because I wanted my object to move, I threw in a direction, and that's going to be a +1 or -1 that we will continuously add to our obstacle. And that way, if we're adding +1, it's going to, the y value is going to increase, so it's going to go down. And if we're subtracting 1 or adding -1, it'll go up. And so that way, by switching that from +1 to -1 and just always adding it, I can have my object move up or down. Okay, so what I do is at the beginning, I say, okay, I want my object 2 that's going to move. I want it to start at 0, and I want to be adding 1 to it each time. So I want it to go from 0 to 1 to 2 to 3. In other words, I want the y value to move down the screen, going from 0 up to the bottom of the screen, which is about 600. Okay, I want my character to start at position 50, 200. Okay, and then I also just say, you know what, my player's width and height are never going to change. So right when I set this program up, I'm going to just say the player's width is 50 and the player's height is 50. And I know that from over here where the player in the character class, I know I just drew a fill rectangle and the width and height were 50 and 50. So just knowing those values, I'm going to set them up right at the beginning. But for the rest of the code, I'm going to use player W and player H just for readability. Okay, then I set everything up here. I draw the background, and then I'm going to draw my main character as long as game over is false, and that'll come in handy later. Notice though, I don't tell it where to draw here. My player X and my player Y are in my character class. So if I want to get access to those over here, I need to use my getters, and that's down here. I have my get X and my get Y that return the X and the Y position. So you'll notice down here when I want to detect my collisions, right before I detect my collisions, I set my current player X value that's in the animate loop that's running, and I set my player's X and my player's Y to the newest, most up-to-date values before I detect the collisions. Okay, the width and height don't change, so I set them once at the top. But the player's X and the player Y, I need to use my getters to get the current position from the character object. Okay, so going back up here, then what I do is I paint my first object. Now, again, I'm using variables, although these are static numbers that are unchanging. I'm just doing this for readability. So right away I set these up. I say, okay, I want my object to be drawn at 200, 500. And I want it to have width and height of 100 by 100. So I want it to be a black square. So I set the color to black. I draw it at position XY, at width and height. And then down here I do the same thing. The only difference with the second object is I'm only going to set up the object X, W, and H. I'm not going to set its Y position. And the reason is if I set the Y position here to say be 100, then no matter what I change in the animation loop, when it comes back here, it's going to reset it to 100. I don't want it to get reset. So I'm going to leave that variable free to change. I'm not going to set it here. I'm going to set the color to black, and then I'm going to draw my object number 2 at its XY with its width and height. Now notice that the Y is free to change here, and that's what I want. So up at the top, remember, I started the object 2's Y position at 0, and I have a direction that I'm going to add to object 2. So then what I do is down in my animation loop, and this is the key pressed, which in another example you can explore, but that's just to move my character. So now in the animation loop, what I've done is I've said, okay, let's put a little wait time in here. And then what we're going to do, and down at the bottom of this forever loop, I'm going to repaint. So I'm going to make some changes, and then I'm going to refresh the screen. So I say, okay, let's wait for a period of time. And then what I'm going to do is I'm going to say I'm going to add to my current object 2Y, I'm going to add the object 2 direction, which is either going to be +1 or -1, right? So if I add +1, it's moving down. And then once it's gotten far enough, and again, this loop's running over and over and over and over every 10 milliseconds. And so once it gets low enough, now you could put 600 if you wanted to go out of the screen and bounce back. But I said I want it to just touch the bottom of the screen. So when it gets to 600 minus the object 2's height, which I could go back up and say, oh, that's equal to 200. So in other words, once it gets to 400, the object 2's height of 200 will be touching the bottom of the screen. So when it gets to a Y position of 400, the 200 additional height of the object will touch the bottom of the screen. Then I want it to turn around. So I switch the object 2 direction to -1. Okay, and then when it gets to the top of the screen, switch it to +1. So object 2 just bounces back and forth. Again, I can show you that. Oh, I've still got this pulled up. Let's just run it. So here's object 2 over here. When it gets to a position of 400, switch. And then when it gets to a position of 0, switch. And then this is just adding 1 to the Y position. Boom, this is adding -1. And all I'm doing is switching that add +1, add -1. Okay. Now, once I've done that, I want to check if my player is colliding with an object. So first I get my player's current X and Y position, and then I simply check, is it in that box that we just talked about? Now let me pull up that image. Okay, so I went and pulled up this image. So this is the location we want to check if our player's X and Y is in. Again, we wrote that as, is the X between the left and the right, and is the Y between the top and the bottom? So all I did is I took those conditionals that we built, which were down here at the bottom. So I just took these four and copied them essentially verbatim, since I have all these variables names, and I put it down here. For readability, I put them on separate lines. So I just said, is the X greater than the left side? Is the X less than the right side? Then I said, is the player's Y, greater than the top of the screen and less than the bottom of the screen? And I did the same thing down here, except I used object number 2's X, object number 2's Y. And it doesn't matter that the Y is changing, since we just have a variable as its placeholder. Now again, since object 2's X, its height, its width are known numbers, you could just replace them with numbers and you don't need all these variables. This just really helps with readability. And all I simply do is, in the animation loop, after I've done the wait time and any animations I want to do, below that I just get the player's current position, check if the player is colliding with object number 1, and then just say, oh yeah, if so, let's set the game to be over. Okay, we had a collision. So boom, player's dead. Okay, if he's collided with object 2, also just say boom, game over. Okay, and then in the end, at the end of the loop, we say, you know what, if this loop is run through and now the game is over, let's go ahead and switch it to ungame over. Let's, bring the guy back to life. But what do we want to do? Well, in this spot, you might want to do all sorts of things. You might want to check the number of lives and have a game over screen. You might want to reset levels. He has to go back to level 1. So there's all sorts of things you might want to do. All I did, not dealing with any of that, is I said, let's just reset the main character's position. So he's not colliding with the box anymore. And then once he's been moved out of the way, now let's switch game over to be false and let's start playing again. So smooth, I didn't do any lives, there's no pause. Just immediately, if he gets triggered game over in one of these two spots, the very next thing that gets triggered is, okay, let's just move him out of the way of that obstacle, and then let's set the game to be false, refresh the screen, and keep going. So I had to go over here, and in character, I just had to make a reset. And all that does is, since I know at the top of my screen in the constructor here, I set the character to 5200 at the very beginning. So when I want to reset my character, I just said, let's reset him to that same position. So in reset, I reset him to 5200. You might want to set these up as variables and have reset taken 2 parameters so that you could do, a reset it to this position. That might be better in your program. Totally up to you, especially if each level has a different starting position. Then you would want to set in a reset depending on if he's in level 1, reset him to here, and so on. Okay, so just to go over it again, this is where the collision is being detected, and we simply say, then set game over to be true, or collision to be true, or whatever you want. Okay, I hope you enjoyed that video. I will post a link to both the code and the PDF that I was doodling on. And yeah, good luck.